Question number 5. It says light traveling through three transparent substances follows a path as shown in this figure. Arrange their indices of refraction in order from smallest to the largest. So this is mu1 media, mu2 media, mu3 media. Light ray is coming like this, then goes like this, and then return back like this. So we can redraw the similar type of picture, and then we can think of this incident angle as theta1 from the normal, of course. So this will be theta2, that is made in medium mu2, and then this is getting reflected back. So you'll find this angle, these two angles are going to be identical, and moreover, laws of reflection will say that incident and reflected angle has to be equal. So this is also theta2, and then again they are going to alternate angles, so theta2, and then finally you'll find it will be coming to the first medium, and we can have the Snell's law. Then whatever the Snell's law was here, the same is going to be valid over here. That will say this angle is also going to be theta. Now we can use the Snell's law in this first boundary, and when it is getting incident, so you write mu1 sin theta1 is equal to mu2 sin theta2. From here sin theta2 can be calculated as mu1 sin theta1 by mu2. Now, since we know as per the figure, we can easily see that the second ray, the ray in this mu2 medium has been shown towards the bending towards the normal. So since it is bended toward the normal, that means theta2 is going to be smaller as compared to theta1. We can clearly see because theta1 is going to be this number entire, and this is smaller number. So this says that mu2 must be denser medium, because in denser medium the light ray bends towards the normal. So mu2 must be greater than mu1. Now let's consider this boundary mu2 and mu3. Here it is clearly shown that the light ray reflected back only, right? Not getting refracted in the medium mu3. That means mu3 has to be rarer, right? Moreover, this angle theta2 must be more than the critical angle, because TIR is taking place. So in this interface, you'll find there's going to be total internal reflection taking place. So we can say theta2 must be greater than the critical angle of this boundary, where critical angle can be calculated like this: mu2 sin theta critical must be equal to mu3 sin 90, because the light goes here when we say the critical angle incident. So from here sin theta c, that means critical angle sine version comes out to be mu3 by mu2. Now since we know theta2 is greater than theta c, so sine is increasing function up to 90 degree, then you say sin theta 2 is greater than sin theta c. That means sin theta 2 is greater than mu3 divided by mu2. Now consider this equation 1, consider this equation 2. And if we solve the two together, then we can put the sin theta 2 value here. So it turned out to be mu1 sin theta 1 divided by mu2 is greater than mu3 by mu2. Mu2 is a non-zero positive number that can be cancelled out. So sin theta 1 is going to be greater than mu3 by mu1. Now this mu3 by mu1 is less than sin theta 1. Sin theta, whatever theta 1 is, sine of that value of angle including is going to be less than 1. That simply says this number is going to be less than 1 for sure. Now if this number is going to be less than 1, that means mu3 must be less than mu1. So we got this mu3 is less than mu1, and we already had mu2 is greater than mu1. Then we can combine them. Then you will find that mu3 is going to be the smallest, and then mu1, and finally largest value will be of mu2. And this order is in option A. Hence we will mark the option A as a right response. Thank you.